Scared of losing all the time. He wrote it in a letter. He was a friend of mine. He heard you could see your future inside a glass of water, the ripples and the lines. And he asked, will I see heaven in mine? That is just the way it was. Nothing could be better, and nothing ever was. Oh, they say you can see your future inside a glass of.
Our first experiment is over evaporation. First, you heat up a pan and then flick water into the pan. The water will evaporate because of the heat. Evaporation of water occurs when the surface of the liquid is exposed, allowing molecules to escape and form water vapor. With sufficient heat, the liquid will turn into vapor quickly. As you heat water towards its boiling point, the molecules in that water move faster and faster. Some of them will fly out of the top of the water well below the boiling point. This is not boiling, this is evaporation.
Evaporation.
The visible steam that comes off the top is not in fact steaming, but it is water vapor. Steam is invisible. If you can see steam, it is water vapor.
Water vapor.
When the water actually reaches boiling point, the water will bubble and invisible steam will pour out of the water.
If you dip your finger into the pepper and water, nothing much happens. If you put a drop of dishwashing liquid on your finger and then dip it into the pepper and water, it will rush to the outer edges of the dish. If you're doing this as a trick, then you might have one finger that is clean and another finger that you've dipped in detergent before performing the trick. When you add detergent to the water, the surface tension of the water is lowered, when normally water bulges up a bit, like what you see when you look at a water drop. When the surface tension is lowered, the water wants to spread out. As the water flattens on the dish, the pepper that is floating on the top of the water is carried to the outer edge of the plate as if by magic. The pepper particle sitting on the surface of the water is being held up by surface tension of the water. It is pulled in all directions except there is no water up. The soap molecules displaces some of the water molecules, but mostly those on the surface. Here, where the soap is on the surface, the water does not pull up the pepper particles. Thus, the other water molecules pull the pepper away from the soap.
First, we're going to comb Paige's hair, and then we're going to put the comb next to the water. And as you can see, the water moves away from the comb. The object that gains electrons becomes more negatively charged, and the one that loses electrons becomes positively charged. The opposite charges attract each other in a way that you can actually see. Static electricity is the accumulation of an electric charge in an object. The electric charge develops when two objects are rubbed against one another. When the objects are rubbed together, some electrons jump from one object to another. The object that loses the electrons becomes positively charged, while the object that they jump to becomes negatively charged. The nature of the objects has a large effect on how many electrons move.
You can cool water below its starting freezing point and then crystallize it into ice on command. This is known as supercooling. We place an unopened bottle of purified water in the freezer. Then we waited for 2.5 hours to supercool the water, and then once we took it out, the liquid was now solid and it had supercooled.
Water is called the universal solvent because more substances dissolve in water than in any other chemical. This has to do with the polarity of each water molecule. The hydrogen side of each water molecule carries a slight positive electric charge, while the oxygen side carries a slight negative electric charge. This helps water dissociate ionic compounds into their positive and negative ions. The positive part of ionic compound is attracted to the oxygen side of water, while the negative portion of the compound is attracted to the hydrogen side of water. Despite its name as a universal solvent, there are many compounds water won't dissolve or won't dissolve well. If the attraction is high between the opposite charged ions in a compound, then the solubility will be low. For example, most of the hydroxic exhibit low solubility in water. Also, nonpolar molecules don't dissolve very well in water, including many organic compounds such as fats and waxes.
Or oil.
As you can see, the water made the salt dissolve, and the salt does not dissolve in the canola oil.
The water, please. How'd it taste?
Good.